You're good, Enzo. Don't worry. All right. So, an inscribed angle is an angle whose vertex is on a circle. So that's, you got your vertex, this guy. And then the red parts are your chords, right? Those are the sides. Okay. And then you have this FDB, that kind of bigger one, is called the intercepted arc. Okay. I always think of it as if it is like kind of a message, right? You're trying to get a message from A and relay it all the way around back to A. And these chords are cutting it off, so the message can't get past here, or past here, right? So it's kind of cutting off the intercepted arc we're looking at is all of this. So similar, we have this with central angles, that the central angles measure however many degrees the central angle is. That's the same as the arc. Okay, these work slightly differently. But there's a connection between this angle here, how many degrees this is, and this arc here. Do you have a question?
Not anymore.
All right, the connection is that's exactly half of the angle. Okay, that the measure of this angle here, is half of this arc. I think that makes sense if you think about this. If you have something like this, I'll try to do this well. Okay, everyone. There's an angle. Yep.
Yeah.
Okay. But the further I go with that angle from my spot originally, if I take this, okay, right, the further this goes out, okay, the smaller, again, if these two sets are stationary, the further you go, the smaller this angle will be.
Yeah.
Does that kind of make sense?
Oh, yeah.
Okay. Demonstrate this way, if I can reach my ruler. Right. Get your math time skills.
I saw it's not from the book. I saw the book there.
I have a math time book.
He has an automatic book over there.
All right. So if you have something like this, and again, this doesn't need to be as long right now, but okay. So let's say, we're down here, right? Notice I'm going to try really hard not to move these two spots. But if all of a sudden that angle goes to the center of the circle, that angle right there is bigger. Thank you. This angle right here is bigger than the one way over here.
Yeah.
Okay. In fact, because this goes to the center of the circle, how far across the circle did it go? Halfway. So if this angle is equal to the arc, then when you go the other half the distance, it's half the size. And so that's the idea that they're trying to explain. Okay. So ultimately, all you need to know is that whatever, they want angle x, you trace that out. This is the angle they're talking about. Think about this as like a little alligator. What angle is it eating?
86.
It's 86. Now, since it's going all the way to the other side, that measure is exactly half. So that's 43 degrees. Okay? Or we could do the opposite. They didn't ask us here. If this is 52, then this one over here is
104.
104. Double.
Ooh.
And the pictures can be of different relationships and try to think through and make you work through that a little bit, but that's the ultimate idea. And so this kind of makes perfect sense. If you have two angles, you've got the blue one and the red one. So you got this guy here. Undo that. Wrong color. You got this guy here. It's eating the green thing. And this guy here is also eating the green thing. What do I know about both of those angles? They have to be the same because they're both going to be half of whatever this green piece is. Like whatever the measure of this is, those will both be half. So the easiest way, let's just make this 100. You know this is 50, and this is 50. Oh, those happen to be equal. Okay, that's how this works. So they'll give you pictures like this.
Set them up together.
Okay. Well, and I want to be careful. You have to make sure you think through. So if I trace this one out, this is angle R. It would be this angle right here, or QRT, and then this other one over here is QST. What did they both start and end with? Q and T. Right. So since they open to the same thing, then they are the same size. So yes, to be clear, I just want to make sure that we see it. You can't just like blindly set them equal to each other. You want to make sure that they're opening to the same thing. And what they'll do is they will do two angles that like don't open to the same thing, but maybe they open to a diameter. So you know they're going to add up to 180, right? Or in that case, they would add up to 90. Okay, and so you can set them equal to 90 when you add them together. You can think through things like that. All right, and again, I'm not worried about like you solving the math here. Like this is the nice thing about geometry is like if you like, I think you guys can all do this. Okay, it is making sure you're careful about your adding, subtracting, multiplying, dividing. Okay, all right. I'm trusting you.
Yeah, that's it.
Okay, all right. Okay.
But they didn't ask for what X was. They asked for angle R.
Yeah, 47.
Okay, so what do you have to do?
Plug X.
Plug it back in. Okay. Freedom for you guys in this case. I guess I should mention this. All right. You can plug it into either one. You can do 5 times 12 minus 13, which is the one they're supposed to do. That's angle R. But this is the exact same thing, right? And I know 5 times 45 plus 2 better than I know 60 minus 13. Not that I couldn't figure it out, but I probably could do this a little faster.
And the answer is 47.
So the measure of angle R is 47. When we plug that back in. Okay. All right. So they're telling you that this is equal to this. Okay. All right.
Figured it out.
Right. Okay, and so go ahead and tell us.
So first, MN is congruent to LO, the segments.
M
And
N.
is congruent to
Okay.
LO. Then M.
We need a reason.
Oh, because the chords are congruent. I'm sorry. The
I got you, yeah. Okay, so again, this is what I would say. There is a theorem. You can sit there and find the number, but it says like in a circle, if the arcs are congruent, then the chords are congruent. And it says, I think the way it's worded is the arcs are congruent if and only if the chords are, which means you can go both ways. Okay, so we've got those. So basically, that's kind of like this. Okay, this is congruent to this.
And then angle M is congruent to angle L because of the two inscribed angles are of the circle intersect the same arc or congruent arcs, then the angles are congruent. Then the same thing for N and O. Angle N and O.
Okay. And within that, sure, let's put another one here. Angle. So you guys see, are we okay that M and L both open up to NO? So those are congruent. And then on the other side, these are congruent. They open up
And
the
then
same.
the triangles are congruent by ASA.
Sorry, 1, 2, 3. Okay. Okay, one of the things I would be really careful about is what is an assumption I would be tempted to make on this proof? Any ideas? Because I think, like, my first thought when I glance at this is to actually just ignore the given and do side, side, side. Well, not ignore the given, use the given, but then do side, side, side. And not focus on this at all.
Why?
Well, because if I hadn't just learned this, this isn't like my first thought all the time. Okay. Here's an assumption that most, like a lot of students will make on a problem like this. They will assume that P is the center of the circle.
Oh.
Okay? And there's nothing that indicates that. Twofold. Number one, they would always tell you circle P if they wanted it to be circle P. Or they would put a big dot right here to indicate that's the center. Okay, since they don't do either of those, we're going to actually assume that that's not the center. Okay? Now there is a way that maybe we could end up proving that it is and go through that. They're not asking us to do that. But I just want to be careful. Like unless they tell us, we want to assume things are not what we would like them to be, right? Okay. Because then you could just do all the radii are the same, right? And you have side, side, side. Or you could have done side, vertical angles in the middle. But since we don't know that, we're going to. Okay. All right. This is just common sense. Okay. This doesn't need to be its own theorem. They're trying to make it better, like quicker for you, right? Can we just understand this? If this angle is always half of this arc, then if this is a diameter, how many degrees is this? And half of that is going to be 90. So this theorem is like, it's really just the same one as the last one we looked at, okay, two things ago. If it's an angle, an inscribed angle intercepts an arc, it's half. Well, this is just a very specific case of that, but the way it's worded focuses on the diameter. So if you ever see this picture, you know that's equal to 90. Okay? Which means this is kind of really nice. Okay? On any circle, if I can do this is an easy way to find the diameter. If I can make sure that this angle right here is 90 degrees, okay? Which I don't know if that is right now. But if I could, what do I know I have? Going across. Okay, then across this thing from this spot, try to pin that down. From this spot, if I let go of this, it's going to fall back to this one over here. Okay, that would be a diameter. Right? It's an easy way to do that. In fact, you can do that with any circle if you simply hold up a 90-degree angle. Let me use this because it's just really thin. Okay. If you hold up something like this, so 90-degree angle, the moment I put this on here, if I mark the two ends, okay, so if I mark this spot here, that side so those don't fall out. You know, if I'm going to mark this spot here, okay, and then this spot here, I know that between my two fingers is a diameter. Okay. And if I rotate this around and do it again, I have another diameter. And guess what happens when two diameters meet? What do you have?
You have.
Come on. Here's a circle. You have a diameter and a diameter.
Perpendicular.
Hold on, but you didn't say it was perpendicular.
I didn't. No, it doesn't have to be perpendicular
The
here.
center of the circle.
Yeah, you end up finding out where the center of the circle is.
Oh,
That's true.
Wherever two diameter meet, which is really important to be able to find the center of the circle. Okay. Okay. So this is a problem that ends up throwing a lot of students off because they feel like they're missing information. Because there's not technically enough here to solve this without recognizing that this is a diameter. Which means that this angle is 90. Which means that these two angles
Add up to 45.
add up to 90.
Yeah, that's what I meant.
They're not necessarily equal to each other. In fact, in this picture, they're not equal to each other if I'm going by the way it's designed. Okay. Not that I want to be misled by the picture.
It's 10.
Okay.
Oh,
No,
X is 10. Well, yeah. Okay, Pastors.
76.
All right, and they want angle B. Okay, so angle B, 8 times 10 minus 4. Okay, how much is angle A?
I don't know. 14.
14.
Okay, that's not hard, right? 14. You plug that in. Okay, and 76.
0.9.9.
Okay, so you have things like that. Like again, there's not enough information. If you miss that, then like that this is 90 degrees. Then like focus. Okay. All right. All right. I left this off so you guys can just think through this with me because again, this is like common sense. If you think and you're like asking good questions. Okay. Let's take this angle. So it says if a quadrilateral is inscribed in a circle, then its opposite angles are. So we're going to take an example. We're going to look at this angle here, and we're going to take a look at this angle here. Okay. So you guys know that this angle is half of whatever this is, right?
Oh, there's supplementary.
Everybody with me on that? Okay. And that this angle here is half of whatever this is.
Are they supplementary?
We'll get there, maybe. How much of the circle right now is covered by blue squiggly and pink squiggly?
All of it.
100.
All of it. How many degrees is the entire circle?
360.
360. So if I took half here and I took half here, that would make them add up to 180, which means they are
Supplementary. I knew it.
supplementary. Okay. Well, supplementary. Again, similar situation where what they're going to do is they'll give you a picture and there's no values to like set things equal to. You have to recognize that things are going to add up to 180. Or it's kind of like a puzzle piece. And you're like, well, these two can add up to 180 and these two can add up to 180. Like, how do I then figure out what those add up to altogether? So you'll see problems that look something like this. This is a pretty straightforward one. Okay. So I just take those two values, 14x plus 8x plus 4. I set those equal to 180. Okay, I did that really fast. I want to make sure I subtracted the 4. I think you guys are good. 14 plus 8 is 22. Do you guys remember the tricks we talked about for 11s? You guys ever remember that?
Oh, right. Yeah. I know my 11 tricks, Mr. Shanks.
11 times 16, you split 16 and then you add the numbers together.
Oh, yeah, that thing.
So when I saw this, I knew this was 11 times 16. Well, but I have 22, which 22 is double 11. Are you with me on that? So what's half of 16? 8.
Well, I just...
Right, so 11 times 16. If I double this one to get 22, I have to take half of this one to get 8. That's just kind of a shortcut. All right, now they wanted the actual angles, so I do have to plug it in. Okay. All right. Yeah, you could do 14 times 8, or you could do this one first. I think we know 8 times 8, 64 plus 8 is 68. How can I find this other one without multiplying 8 times 14?
Oh.
Yeah. Yeah, 180 minus 68. Okay. Oh, yes. Well, that's really easy. But I want to make sure we understood these two first. Okay. Yeah, we weren't done. So that's angle T. Okay. We also found angle U. Let's say if this is 90, how much does this one have to be?
9.
This just has to be 90. Because those two add up to
180.
Yeah, we weren't done. I just wanted you to see, like, you can find out all the values.